Hello students, welcome to my channel Science No Problem. My name is Tish Sharma and I am teaching you science. So my dear students, like our previous videos, this video is also going to be very informative and very useful. So please watch the video till end and please don't forget to like, share and subscribe our channel to motivate and support me so as to bring you far more useful and far more informative videos in future as well. So my dear students, without wasting any time, let's start our today's video. So my dear students, as you know, we have started a series of MCQs. So this is our third video of MCQs on chapter magnetic effects of electric current. So please watch the video till end. So my dear students, the first question which we are taking is a soft iron bar is inserted inside a current carrying solenoid. That means that soft iron bar is placed inside a current carrying solenoid. You know what is solenoid. So the magnetic field inside the solenoid. So this is, my dear students, solenoid, and this is soft iron bar. So this is placed inside the solenoid. So my dear students, always remember that when this soft iron bar is placed inside solenoid, the magnetic field inside the solenoid will always increase. Even this actually the piece of iron which we have placed inside solenoid, so that becomes magnet. So please remember this. So that is called electric magnet. So B is correct. Question number 2. The magnetic field lines in the middle of the current carrying solenoid are. So my dear students, always remember that magnetic field lines in the middle of current carrying solenoid are always, suppose that this is axis of the solenoid, so they are always parallel to the axis of the solenoid. And actually, you know the pattern of magnetic field lines produced in solenoid. They are like magnetic field lines produced by bar magnet. So like this. So this is, say, N pole. So from N pole, magnetic field lines originate and they terminate at S pole. So this is S pole. So in the middle of the solenoid, magnetic field lines are parallel to the axis of the solenoid. So parallel to the axis of the tube, that is C is correct option. Now my dear students, we have question number 3. The front face of a circular wire carrying current behaves like a north pole. The direction of current in this face of the circular wire is. So my dear students, now understand the question. This is circular loop. So front face of circular wire carrying current. So in this wire we have current. This behaves like a north pole. So N. So my dear students, actually place a arrow at the ends of this N like this. Now this is arrow is in downward direction. So place arrow on this loop also in downward direction. Here this is in upward direction. So place actually arrow on this loop in upward direction. Now see the direction of the current in this actually loop. So this is anti-clockwise. So C is the correct option. So here current will be in the anti-clockwise direction. Next question is, the back face of a circular loop of wire is found to be south magnetic pole. So now this is found to be south magnetic pole. Now you will write S here, S for south, and at ends of this S, place arrow. Now this arrow is in upward direction, so place arrow in upward direction on this loop. Here this arrow is in downward direction, so place arrow in downward direction on this loop. Now see the direction of current in this loop. This is in clockwise direction. So which one is correct? B is correct. Now my dear students, we have question number 5. In an electric motor, the direction of current in the coil changes once in each. So my dear students, always remember, or you might know this, that in an electric motor, direction of electric current changes after each half rotation. So C is the correct option here. Please remember this. Question number 6. An electron beam enters a magnetic field at right angle to it as shown in figure. So my dear students, you can see the direction of magnetic field in forward direction, and this is the electron beam is in downward direction. So the direction of force on this beam of electrons will be, so my dear students, electrons are moving downward direction, and movement of electron is current. So it means current is in downward direction, and magnetic field is in forward direction. So actually the direction of force on this beam of electrons will be out of the page using Fleming's left hand rule, which says that our forefinger points to the direction of magnetic field, middle finger points to the direction of current, and our thumb points to the direction of force exerted. So here D is the correct option, out of the page. Now my dear students, we have question number 7. The force experienced by a current carrying conductor placed in a magnetic field is the largest when the angle between the conductor and the magnetic field is. So my dear students, when the force experienced by a current carrying conductor placed in a magnetic field is maximum. When maximum force will be exerted? When the angle between conductor and the magnetic field is 90 degrees. So please remember this. So for example, this is a direction of magnetic field, and this is actually in this direction, vertically downward direction. If this conductor is placed, then if the angle between these two, now angle is between these two is 90 degree. So in this case, maximum force will be exerted on this conductor. Now we have question number 8. What is question number 8? The force exerted on a current carrying wire placed in a magnetic field is 0 when the angle between the wire and the direction of magnetic field is. So my dear students, now direction of magnetic field is in this direction, forward direction, and if we place current carrying conductor or current carrying wire in this direction, in the opposite of direction of magnetic field, so now the direction of current will be in this direction, so angle between them is 180 degree. So when angle between current carrying wire and the magnetic field is 180 degree, then force exerted on this current carrying wire will be 0. So please remember this. So D is the correct option. So my dear students, this is all for today. So I hope that the questions which we have discussed in this video, you know them very well. So if you like this video, then please like, share and subscribe our channel. Thank you very much for watching this video. So keep watching our channel, keep learning and keep growing. Good luck.